Happy Kleenex Friday. Yay. Huh? How many days? 20 days until school ends. Oh, 20, yeah. And 29 days until Zoe's birthday. Yay. My 8-year-old, who will be a 9-year-old then. Yay. Okay. So these trigonometric functions that we're going to study are periodic functions. So periodic functions, oh, I didn't even check to see if my pen was working. Come on, pen. My pen is working. There we go. It'll be back. There we go. So the functions that we will study will look more like these two on the bottom. But here are some other examples of periodic functions. So with periodic functions, you see a repeated pattern. And the pattern is always the same width and the same height as it repeats. So if I think of this top picture, let me find, it's a periodic function because it's going up and down, and it's always in the same width. It's always between these two horizontal lines. And it is, come on. Oh, so and each little pattern is the same width. So let me just pick a place to start it. Let's say I start it right here. And if I, oh, you can't see that one? We'll do purple. Can you see that one? Okay. Let me highlight in purple. Okay. If I start down here, that highlighter is way too big. Thick. Then we have thin, chisel, point. Okay, let me try this. Oh, that's going to be even worse. Never mind. Let me go back and just use a pen. All right. So let's say I started down here on the bottom, and I go along on this periodic function till I get back to where I started again, and that's called one cycle. Okay? So, or I could have started right, let's see, I could have started right here and travel along until I get back to where I started again, and there's one cycle. Or I could have started right here and travel along this function till I get back to where I started, and that's one cycle. On the one with the little squares, maybe I could start right here, travel along until I get back to where I started. There's one cycle. The width of one cycle is the period of the periodic function. So the width of one cycle is its period. So let me see, maybe I can grab a point off the x-axis. Maybe this is 3 on the x-axis, and maybe this is 5 here, and this being, I guess, if that's 5, that's going to be 7. Now, if I'm going to start here. One length of one cycle gets me all the way back. There's one cycle. No, I have to get back to where I'm started, and I start my pattern again. So the width of one cycle is, oh, I'm going from 3 to 7. So 7 minus 3 equals 4. This one has a period of 4. And no matter where I start the cycle, it should always have the same width of a single pattern. So the period will be constant. It will always be the same. Okay? And if I think about the how tall this periodic function gets, so let me go down to, let's say, this one. And I think about a horizontal line going through the top and the bottom here. And maybe this is at -3 and this is at +3. The height is represented by a measurement called amplitude. It's just like physics, exactly. And the amplitude is actually 1/2 the height. So this one has a total height of 1, 2, 3, 4, 5, 6. So its amplitude is 1/2 of 6, which is 3. Thank you. And so, oh, here's a funny looking little function here. It is periodic. I do see a pattern here. If I think about starting this one, oops, I can't start it in blue. If I think about starting this one right here, we go up and around and down and around and around, and we get to there, and there's one cycle. So whatever this width is, say this was at -15, and this is at -7, its period is -15 minus -7, absolute value of that, 8. And if we went from, let's say, 5 at a height to -3 at the lowest point, then its amplitude is going to be, oh, the distance between 5 and -3, oh, that's 8. So 1/2 of 8, its amplitude is 4. That's basically all you're going to be working on today, but we'll go a little further here. Here's a function that's not periodic. It does have some pattern, but it doesn't always have the same height and the same width for your pattern. So to be periodic, your high point and your low point always need to be between the same two horizontal lines, and here that changes. And your widths need to be the same. So the amplitude's got to be the same for every cycle. The period's got to be the same for every cycle. Otherwise, it's not a periodic function. All right. And a sound wave. So here we get into physics here. So some sound waves are periodic functions. Some of them aren't. From my understanding, some of them aren't. But here's one that is. And it's going to look like one of our trig functions here. It's actually going to look like sine. And so, if I see a picture of this, or if I'm asked to draw one, I need some scale here on my axes. Well, let's say that this cycle on this one, let's say that the period on this one is 0.1. So to go from one full cycle, oh, that'd be this whole picture here. Gets me to 0.1. Half a cycle would be at, I wonder what halfway between 0 and 0.1 is.